So what we want to do here is kind of reverse the process. What if we have the composite function? Can we recognize what functions make up that composite function? Can we visualize the inner and outer functions? And with this, there's a few ways to go about it, and I'll explain it a few ways that I like to teach it. One way is kind of following order of operations, or kind of following our variable rather. And the other is just kind of visual, of seeing what's going on the inside, what's going on the outside. So what we're going to do with this is we have these functions h, and they're made up of two functions. We have f of x and g of x. And we're looking at f of g of x, where g of x is the inside function, and f of x is the outside function. So let's look at this first example here. So what we want to do is see what's the inside function and what's the outside function. So it can be easiest, well, I shouldn't say it's easiest because it's just different for different students in terms of how you see this. If you follow the variable x, so if I'm looking at x here, what I can see is like, okay, we're going to multiply with 3 and then we're going to add 1. So what I can imagine is if I plugged in a value for x there, I would simplify everything under the square root first. That would be my first step. So I kind of save the square root for last. And what that tells me is that that operation right there is one function. It's kind of grouped together. This multiplication and addition, we can do that together easily without kind of changing gears. So what that tells me is, in terms of an outside and inside function, this would be my inside function. Kind of what we would calculate first, because we start with our inside function. And then at the end of the function, then we take this square root. But what you can visualize too is the square root's happening on the outside of everything, and that 3x plus 1's trapped inside. So that kind of visually as well brings through the idea of an inside and outside function. Now, when we write the outside function, so I'm going to have my square root, I don't want to write 3x plus 1 here. I want this idea of, well, we took this 3x plus 1 and plugged in there, and what it had to replace was our variable. So when we write our outside function, kind of want to look for where your inside function went and replace that with an x. So let's check this, because sometimes through the checking of it, it can become clearer why this is working. So h of x is made up of f of g of x. And what we're saying is that g of x is equal to 3x plus 1. So when we have just, oops, I don't want to use a pen there. When we have just x here, then when I go to f, my function f is defined by as we take the square root of whatever our input is. And we're saying the input is 3x plus 1. So that's where we just want our variable x there so that it can make that replacement in that location without any other outside operations occurring. So then we can see our square root of 3x plus 1. So kind of two ways is to think about what calculations would you do on x first, and then what would you do in a second step, and that kind of separates the idea of inside outside, but also just visually what's the kind of the inside operation, what's the outside operation. So let's look at some more of these. So with this one, I could imagine if I plugged in a value for x, I would square it and subtract 1. So that could be kind of a first step of simplifying. And then at the end, we're cubing. We can also see this idea that we have what's happening on the inside of the parentheses, and then what's happening on the outside of the parentheses. So for inside and outside function, so f of x and g of x, the inside I see this x squared minus 1, so that's what I would input, and then what I want to do to that inner function is cube it. So for f of x, I want to take whatever my input is and cube it. So let's check. So we're taking f of g of x, So f of and g of x is equal to x squared minus 1. F is telling us to take whatever our input is and cube it, and our input is that entire x squared minus 1. So with that, we can see a form that exactly matches what we started with. This next example is pretty much identical. The idea, if we plug in something for x, we would do this 5x minus 3 first, and then our last step would be to carry out that exponent of 2. So for inside and outside function, and as you can see by my writing, I start with the inside function first, and then our last operation is to take whatever that input is and square it, which would be like x squared. So again, we could check that, where h of x is equal to f of g of x, where g of x is equal to 5x minus 3. F is telling us to take whatever our input is and square it, and our input is 5x minus 3. Alright, our last one here, a little more complicated. What we could see is that there's this input to our function. We have the same input where we see x where it's a cube root of x. So let's think of that as our inside function. It's like whatever we have for x, the first thing we would do is take the cube root of it. So it's like if I plugged in 8 for x, I would simplify that value in the numerator, I would simplify that value in the denominator. And then my second step would be to simplify the rational part of the function. So this is telling me that in terms of inside and outside function, that inside function is just going to be the cube root of x. So visually, what we have here is like we have that input of cube root of x over that input of cube root of x plus 1. And this gives me a framework for my outside function, because I can see how that went to the input values. And when we make this for our outside function, where we can see where we had our input before, we just want to replace that with x. So my outer function is going to be x over x plus 1. So let's check that. So h of x, f of g of x, which we're saying is the cube root of x. And then f of x is telling us to take our input over input plus 1, and our input is cube root of x, which we see in 2 spots. And we can see how that matches exactly. So, part of it is visual, part of it is calculation, but while it's not required to check your answers, I highly recommend it to make sure that it was done correctly.